Good morning. Namaskar. Am I audible? So, in the last class, we were talking about the various types of atomic models. Now, let us proceed here onwards. Let us suppose we have one atom. This is the nucleus and this is electron. Suppose we have another atom. This is nucleus and electron. So, these nucleuses these atoms first of all will start experiencing attractive force. This nucleus will attract this electron and this nucleus will attract this electron. So, some attractive forces will work on these nucleuses. They are given as these atoms, basically they are given as 1 by 4 pi epsilon naught q1 q2 upon r square. Obviously, both charges will be opposite, so value of this force will be negative. Let us suppose I plot this force. See, if I plot this force, it would be looking like this. This axis I am taking interatomic spacing. Interatomic spacing means the distance between the two atoms. And at this axis we are plotting force. So, let us suppose here I am plotting attractive force. Don't get confused by the magnitude, by the sign. Suppose here we are taking attractive force, so obviously the repulsive force would be downward because both are opposite in sign. If we are representing attractive force this side, repulsive force will go upside. So, this attractive force is varying with square of the distance. So, as the interatomic spacing decreases, the force increases. In other words, with increase in interatomic spacing, the force decreases. So, this is attractive force. This is Fa, right? Now, suppose I talk about repulsive force. Suppose I talk about repulsive force. Why I am talking about repulsive force? When these these atoms will come closer to each other, the outer orbit electrons will start overlapping each other. So, some repulsive force will also start working on these two atoms, and that can be also given as 1 by 4 pi epsilon naught q1 q2 r square. Although it would be between the same types of charges, so magnitude wise the nature of the force is just like attractive, but sign wise they will be opposite. So, let us suppose repulsive force is working like this. At some interatomic spacing, the magnitude of these forces is, let us suppose, same. Suppose I am assuming the magnitude of these forces is same at some interatomic spacing. इन दोनों forces का magnitude कुछ interatomic spacing के लिए same है. Let us suppose at this point. At this point, the force value is same. Let us suppose this is R naught. This is again R naught. Sorry, this is not R naught. This is Fa and this is Fr. So, magnitude of Fa and Fr is same at this interatomic distancing. Means if I plot the net force, so below this repulsive force is dominating, and at this point the net force is 0, above this the attractive force is dominating. This is the graph for the net force. So, at some distance R naught, the net force on these two charges is 0. Yeah, these two atoms is 0. F net is equal to Fa plus Fr. So, at R is equal to R naught, equilibrium interatomic spacing at r is equal to r naught, equilibrium interatomic spacing, F net is equal to 0. That is Fa plus Fr is equal to 0. Net force is 0. Now if the net force is 0, then they will become stable at this point. At this interatomic spacing, they will become stable. This distance between two center atoms is r naught. So this net force, which is sum of attraction plus repulsion, this is equal, this is basically keeping them together. Now at this point, if you want to decrease the further spacing, then repulsion force will start working and it will not allow you to decrease the spacing between the atoms further. Suppose beyond this point, you start increasing the spacing between the two atoms, then attraction force will start working and that will not allow them to go away. Hence, the combination of this attraction and repulsion is not allowing the distance between the atoms to decrease below r naught and not allowing to increase. It means it is keeping these two atoms together at r naught. So this force is binding these two atoms and that's why it is known as atomic bond. Yes, sometimes also known as chemical bond. This atomic bond is because of the electrostatic force. These forces are electrostatic force, which is nothing but known as Coulombic force. So the reason behind the atomic bonding is Coulombic force. Popularly it is known as chemical bond. So now we can define chemical bond properly, and that definition is chemical bond. That definition is the binding force between the two atoms, the binding force between the two atoms, the binding force between the two atoms is known as chemical bond. The binding force between two atoms is known as chemical bond, right? And that force is nothing but the electrostatic force. How it is behaving, that I have shown in this graph. So you can proceed for today's discussion like this. No, Manjeet, it's not van der Waal attraction. Both forces are Coulombic force. Regarding van der Waal force, I will be talking later. The heading, someone asked, heading you can give chemical bond, yeah, atomic bonding, whatever you want. You can put the heading chemical bonding. आप हिंदी बोलते हो तो बहुत अच्छे लगते हो सर। यार मैं मजबूर हूँ और आप मेरी मजबूरी समझ नहीं रहे हैं। आप मुझे ऐसे बोल के शर्मिंदा कर रहे हैं। अरे बेटा, नेट फोर्स, क्या मजाक कर दिया आपने। प्रोफाइल सेम है, अट्रैक्शन किसके बीच में लगेगा? न्यूक्लियस एंड इलेक्ट्रॉन्स के बीच में। रिपल्सन किसके बीच लगेगा? इलेक्ट्रॉन्स एंड न्यूक्लियस। So both atoms are experiencing two types of forces, some attractive and some repulsive. So net force on these two atoms is what? Sum of attraction plus repulsion. अब मैं कह रहा हूं कि when the sum of attraction plus repulsion is becoming zero, they will become stable, right? and that point at which they become stable, that is known as they are bonded together. कैसे कैसे डाउट कर लेते हो भाई, ये सिर्फ अट्रैक्शन दिखा रहा हूं, ये सिर्फ रिपल्सन दिखा रहा हूं, इन दोनों का नेट इस लाइन से दिखा रहा हूं। आप लोग क्वेश्चन पूछते वक्त जरा सा सोचते नहीं हो कि व्हाट यू आर आस्किंग। मतलब आपने पूछा है कि दोनों की प्रोफाइल सेम है तो नेट फोर्स कैसे हुआ, मतलब दो सेम प्रोफाइल के फोर्स ऐड नहीं हो सकते। कहां से सीख लिया इतना गूढ़ ज्ञान? यस धैर्य, आप बताइए एनर्जी के साथ क्या होगा? रोहित शर्मा जी, डिड यू गेट द पॉइंट और नॉट? Yes, repulsive force will be between the nucleuses as well as it will be between the electrons, both. Please note down. Good. Written? Now you see, my dear friend, in the last class I told you that when any system is stable, its energy will be minimum, and at this point both of the atoms are in stability. They are not going away, they are not coming closer, they has become stable. So it means at this point their energy should be minimum. So as of now they will have only potential energy because they are not in motion. If they would have been in motion, then they would have been kinetic energy also. But since they are not in motion, so they will have only potential energy. So these electrons, these atoms potential energy of this system is minimum. That potential energy which is minimum at this point is basically known as bonding energy. In fact, bonding energy is not the energy of the system. It is the energy required to break the bond. So magnitude wise both of energies will be same. So we need to supply some amount of energy to break this bond so that these atoms can be thrown away. So when we supply some amount of energy required to break this bond, that amount of energy is known as bonding energy. Greater the amount of energy required to break the bond, it means lower has been the potential energy, more has been the stability, and strong is the bond. So bond जितना मजबूत होगा उतना ज्यादा हमें एफर्ट करना पड़ेगा बॉन्ड को तोड़ने के लिए. स्ट्रॉन्गर द बॉन्ड वी हैव टू पुट मोर एनर्जी टू ब्रेक द बॉन्ड. सो बॉन्डिंग एनर्जी वुड बी हायर. सो हियर आई वुड लाइक टू डिक्टेट फ्यू पॉइंट्स. सो प्लीज समझे. Please write down few points. When two atoms are, please note down few points. When two atoms are at large distances, when two atoms are at large distances, at large distances, the interactions are negligible. The interactions are negligible. The interactions are negligible. But as the atoms approach, each exert force on the other. Each exert force on the other. On the other. These forces are of two types. These forces are of two types: attractive and repulsive. Attractive and repulsive. These forces are of two types: attractive and repulsive. Full stop. Next point. The origin of attractive forces, the origin of attractive forces the origin of attractive forces depends on the particular type of bonding depends on the particular type of bonding. Particular type of bonding that exists between the two atoms. That exists between the two atoms. Full stop. That exist between the two atoms. Full stop. Ultimately, the outer electron cells of two atoms begin to overlap. And a strong repulsive force comes into picture. Full stop. The net force between the two atoms, जस्ट अभी शुरुआत हुई है अरुण वशिष्ठ, पहला पेज है. The net force between the two atoms is just sum of the both attractive and repulsive forces. Attractive and repulsive forces. Full stop. When net force is equal to 0, when net force is equal to 0, then a state of equilibrium exists. Then a state of equilibrium exists. Then a state of equilibrium exists. Full stop. The centers of the two atoms, the centers of the two atoms, the centers of the two atoms will remain separated, will remain separated will remain separated by equilibrium, by equilibrium interatomic spacing, by equilibrium interatomic spacing. By equilibrium interatomic spacing. Full stop. Once in this position, once in this position, once in this position, the two atoms will counteract, the two atoms will counteract any attempt to separate them, any attempt to separate them. Any attempt to separate them. By an attractive force. By an attractive force. Or to push them together, or to push them together, to push them together. By a repulsive force, by a repulsive force. Full stop. Next point. We can observe that we can observe that when bond is formed, when bond is formed, when bond is formed, Net potential energy is minimum. Net potential energy is minimum. Net potential energy is minimum, full stop. This minimum potential energy is known as this minimum potential energy is known as bonding energy. Bonding energy. Bonding energy, full stop. It represents the energy. It represents the energy. It represents the energy it represents the energy that would be required to separate two atoms to an infinite distance. That would be required to separate two atoms to an infinite distance. Means it is the amount of energy required to break the bond, that is known as bonding energy. So you can say that बॉन्डिंग एनर्जी को एक लाइन में मैं लिखना चाहूं, सो आई कैन राइट इट इज द अमाउंट ऑफ एनर्जी, it is the amount of energy required to break the bond. It is the amount of energy required to break the bond. It is the amount of energy required to break the bond. अब हमारे पास दो तरह के केमिकल बॉन्ड होते हैं. We are having two types of chemical bond. One, when the bond is formed between two atoms like hydrogen and chlorine. These are two atoms. So a bond has been formed between these two atoms. So it has become a molecule. Now suppose one molecule and another molecule attract each other. So if any bond is formed between two molecules, then it will be known as secondary bond. And if a bond is formed between two atoms, it is known as primary bond. So you can classify the bond in two broad categories. One, primary bond, which is a force between two atoms, and another secondary bond, which is a force between two molecules. The force between the molecules is known as van der Waals force, and the force between the atoms is known as electrostatic force. So primary bond is because of electrostatic force. Electrostatic forces are very strong, so bond is also very strong. Secondary bonds are due to van der Waals forces. Van der Waals forces are weak, so bond is also weak, right? So we can classify this bond in two broad categories, and first category is chemical bond. It can be classified as, first one is primary bond. Primary bond, and the second one is secondary bond. Primary bond में we can write it is inter-atomic bond, and it is electrostatic force. basically attraction and repulsion. It is electrostatic force, that is Coulombic force. Coulombic force. And bond is strong, and if it is strong cannot be easily broken, so it is stable. Here it is intermolecular bond. Intermolecular bond. It is due to van der Waals force. van der Waals force क्या है ये आगे चल करके बात करेंगे. So it is due to van der Waals force, and van der Waals forces are weak, so this bond is weak and unstable. Please note down. Now one by one we will try to study all these bonds. Please note down. We have broadly three kind of primary bonds. They are ionic, covalent and metallic. So we need to study all these three kind of bonds. Similarly, we will be studying three types of secondary bonds also. Please note down. Let's go for the next. Done? Now, in primary bonds, we will be trying first to study the ionic bond. The classical example of ionic bond is NaCl, bond in the NaCl. Sodium has atomic number 11. So in the first orbit it will have 2 electron, then 8 electron and then 1. Chlorine has atomic number 17. So in the first orbit it has 2, then 8, then 7. Now my dear friend, let us see, this is the sodium atom nucleus, and it has 3 orbits: first orbit, second orbit and third orbit. In the first orbit there are 2 electrons, 1 and 2. In the second orbit we have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8 and then 1 electron. Similarly, if I talk about chlorine, so chlorine is having 1 orbit, second orbit, third orbit. In the first orbit you are having 2 electrons. In the second orbit 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Right? Now you see, dear friend, sodium will try to complete its octet, but it is having only 1 electron in the outermost orbit. So it is not possible for sodium to get 7 more electrons. So sodium will have tendency to give up this outermost orbit electron. Chlorine has 7 electrons. So it is very close to completing its octet. So it will not try to give up electron. Instead, it will try to take electron. Basically, sodium is electropositive element and chlorine is electronegative element. So this electron will come from sodium to chlorine. As soon as sodium gives up its electron, it becomes Na plus. So Na gives electron and it becomes Na plus 1 electron. This Na plus is known as cation. Similarly, Cl plus electron, it becomes Cl minus and it is anion. Now these cations and anions will attract each other with a strong force, and that force is known as ionic bond. So basically the force between the cation and anion, the force between cation and anion, is known as ionic bond, Since it is a force between two oppositely charged ions, so this force would be very strong. So this bond would be very strong. Bond is strong, it means bonding energy would be very high. We will be requiring very high amount of energy to break this bond. So bonding energy is generally in the range of 1500 kilojoule per mole, which is very high amount of bond energy. It means melting point of these compounds will be very high, because if you are wanting to melt them, it means you are providing thermal energy. So you need to increase temperature very high, then only you can provide the sufficient thermal energy to break this bond. So melting point of these materials is very high. Basically these bonds are formed between metallic and non-metallic elements. Sodium is metallic element and chlorine is non-metallic element. So ionic bond is formed between metallic and non-metallic element. Ionic bond is formed between metallic and non-metallic elements. Metallic and non-metallic elements. Ionic bond is formed between metallic and non-metallic elements. Chemistry has two types of compounds. One which are carbon based compounds. The one which are carbon based compounds, they are known as organic compounds. But those which are not carbon based, they are known as inorganic compounds. Here we are making a compound with the help of metal and non-metal. So there is no contribution of carbon. It means it is an inorganic compound. So these are inorganic materials. Yeah, ionic materials are inorganic compounds. Ionic materials are inorganic compounds. Inorganic compounds. Since attraction force is very heavy, so atoms will come very close to each other. So interatomic spacing would be negligible, and hence you will always get crystal in the natural state. So these are naturally crystalline materials. These are naturally crystalline material. Crystalline, as of now, you can consider like solid material. When solid is formed, you see certain kind of structure can be developed. But before that, one small thing. Since this orbit, this electron has gone, so no role of this orbit. You can neglect this orbit. Now the effective size of the cation is up to this. So this is known as cation radius. So up to the second orbit. But this element has retained all the third orbit. So radius is up to the third orbit. Obviously you can say that now the anion is larger in size than the cation. It means Rc is smaller than Ra. So cations are smaller in size than the anions. This is very important point. It has been asked in the examination. Why cations are smaller? Because they give up their outermost orbit electron, so their effective size is reduced. Whereas anions contain all the electrons, contain all the orbits, so their effective size will remain same. So we can say that cations are smaller in size than anion. Cations are smaller in size than anions. Cations are smaller in size than anions. Now my dear friend, let us suppose I am representing few things. Suppose this is a cation, sodium, Na plus, a smaller one, and this is chlorine, Cl minus, larger one. So Na plus, smaller one. This I am representing Cl minus. Then again Na plus. I am wanting to their three-dimensional arrangement view. Just trying to show you one cross section. Then here you will have Cl minus, Cl minus, and Cl minus. So this is Cl minus, Cl minus, Cl minus. Then you will have Na plus, Na plus, Na plus, like this. Then again you will have here Na plus, Na plus, Na plus, and then Cl minus, Cl minus, Cl minus. What I am wanting to show you, you see, this cation and anion attract each other. This cation and anion will attract each other. They will attract each other. So these will also attract each other. They will also attract each other. They will also attract each other. Like this. Suppose there is an anion that will be attracting. There is an anion that will be attracting. There is a cation that will be attracting. There is a cation that will be attracting. Here also all the cations and anions are attracting each other. They are attracting each other. Attracting each other. This kind of three-dimensional network you may get from these cations and anions. These are the bonds. These are basically ionic bonds. Anywhere if you see, these are bonds, ionic bonds. Now you see, my dear friend, if you see from any anion in each direction, you will get equal magnitude of ionic bond. Or you see any cation in each direction, you will get equal magnitude of ionic bond. Such bonds which have equal magnitude in all the directions, they are known as non-directional bond. So ionic bond is non-directional bond. Means it does not have any specific direction. It can be formed in any direction. Whereas in the later sections I will teach you some bonds which are directional. Like you see, if you recall, in water you will have the bond like 104.8 degree. It means only at this angle the bond is strong. So if the bond is formed in any particular direction, then that would be known as directional bond. But ionic bonds are not formed in any particular direction. They are equally strong in all the directions, so they are a non-directional bond. What is the beauty of non-directional bond? The beauty of non-directional bond is, okay, let us suppose I consider this cation. So this cation will try to accumulate as much possible as anions in its surrounding. So it will try to densely pack it. In the given volume, it will try to pack maximum number of opposite ions. Similarly, if you see any anion, then it will try to attract maximum cations. So we can consider any one and explain accordingly. So let us suppose I am considering cation. So because of this non-directional bond, this cation will try to attract as much possible as much anion. Basically, the structure would be something like this. Okay, let us suppose anions are very large in size than the cation. So these are anions, these are anions, these are anions, and these are anions. So any cation will be between these anions and it will be touching to all these anions. Touching means it is attracting to this, it is attracting to this, it is attracting to this, it is attracting to this. So this kind of structure you would be getting. Yani in a given volume, there will be very less number of voids. Most of the space is occupied by the ions. So mass per unit volume would be very high. Density of these ionic materials would be very high. So let us write this point as well. So next point I am wanting to tell you, कि ionic bonds is non-directional. Ionic bond is non-directional. Non-directional. Ionic bond is non-directional. That means the magnitude of the bond is equal in all directions. The magnitude of bond is equal in all directions. Is equal in all directions. Is equal in all directions around an ion. Around an ion. Ionic bond is non-directional, that is the magnitude of bond is equal in all directions around an ion. It follows that ionic materials are, it follows that ionic materials, it follows that for ionic materials लिख लेते हैं, it follows that for ionic materials to be stable, follows that for ionic materials to be stable, all positive ions must have as much as possible negative ions, as much as possible negative ions in a three-dimensional space, in a 3D space, in a 3D space. So this is all about the ionic bond. Few more important things you see. Since these two neighboring atoms are strongly holding to each other, so it is not possible to displace any atom without breaking bond. So if displacement of atom is not possible, then we cannot change the shape of the material by applying some mechanical force. So material cannot be ductile or malleable. It is brittle. If you apply excess force, the bond will break and material will suddenly break into two pieces. So these materials are not ductile. These are hard and brittle materials, and these properties are direct consequence of the atomic bonding. Because of the strong bonding between the neighboring atoms, it is not easy to displace any atom, and if the atom cannot be displaced, then shape of the material cannot be easily changed, and hence material cannot be considered to be ductile or malleable. These materials are considered to be the brittle materials. So ionic materials are brittle materials. Ionic materials are brittle materials. या hard and brittle लिख लें, that would be better. Hard and brittle materials. Ionic materials are hard and brittle materials, right? Next point. You do not have any free electron, although you have lots of charges Na plus Cl minus, but they are the bound charges, and bound charges cannot move, and if they cannot move, they cannot contribute into the current. Hence, you will not have any current through the material. And if there is no current through the material, it means this material is electrical insulators. Most of the students get confused by watching the charges. This should be conductor. No, this is not conductor. What is the definition of conductivity? Ability to conduct current. And what is current? Current is rate of flow of charge. Charge can flow only if it is free, but here you do not have any free charge. All these charges are bonded, so they cannot move until the bond is broken, and in the natural state bond is not broken. So in the natural state these charges are not capable of moving, hence they cannot contribute into the current, and hence this material is electrically insulated. In fact, ionic materials are excellent insulators. So these materials are electrical and thermal insulators. Electrical and thermal insulators. Due to absence of free electrons. Bonding energies generally range between 600 to 1500 kilojoule per mole. 600 to 1500 kilojoule per mole. 600 to 1500 kilojoule per mole, which are relatively large, and hence high melting point. So these are some characters related with the ionic materials, and you please go for these. लिख लीजिए जिन्होंने ना लिखा हो, quickly. Anup Malik ji is asking, can van der Waals force win over the electrostatic force? Never in its life. Electrostatic forces are always far stronger than the van der Waals forces. Any van der Waals force can never win over the electrostatic force. Please note down quickly. GATE exams dates are announced. Mechanical engineering 4th February and timing 2:30 to 5:30. Electrical engineering 5th February 9:30 to 12:30. EC 5th February 2:30 to 5:30. Then civil 12th February CE1 and CE2, it means it has been conducted in 2 sessions, 9:30 to 12:30 and 2:30 to 5:30, both on the 12th. So exam dates has been announced. You are an idiot. I said that when the bond is formed, then what? These ions are bonded with each other. So these ions are not able to move and hence current is zero. When salt falls into the water, then chemical reaction took place. Salt get dissolved in the water. Salt get dissolved in the water means these bonds are broken. Then only the solid will dissolve into the liquid. And when these bonds are broken, then it is not salt. In fact, it has become salty water. So salt is not good conductor. Salty water is good conductor. थोड़ा सोचा करो, दिमाग लगाया करो, सुबह सुबह भांग खा के मत आया करो क्लास में. Salt and salty water both are same thing. Do you feel it? तो फिर सारी दुनिया एक ही है. साइंस के स्टूडेंट हो, मजाक मत किया करो. चलो, प्लीज नोट डाउन. ये लिख लिया होगा आपने ऊपर का, यहां से लिखना शुरू करें. अच्छा, ionic materials are generally soluble in polar solvents like water. Some ionic materials are soluble in polar solvent. Polar solvent means water. Some ionic materials are soluble in polar solvents. They dissolve in polar solvent. गेट का सिलेबस 11 महीने में नहीं कंप्लीट हुआ. हाउ कैन आई एक्सेप्ट इट? गेट का तो सिलेबस कंप्लीट हो गया है. किस ब्रांच से हो सौरभ जी? ईआई तो ब्रांच नहीं होगी, आईएन होगा. निष्ठा गोयल जी, है ना? आईएन पेपर इज ऑन व्हिच डेट? आई हैव नॉट सीन. लेट मी सी. हाँ, आईएन इज ऑन 11th February and EC is on 5th February. So both are different. ऋत्विक, आप EC इलेक्ट्रिकल से हो क्या? अगर EC इलेक्ट्रिकल बैकग्राउंड से हो तो ब्रिटलनेस हार्डनेस के लिए वेट करिए. आई विल बी टीचिंग अ चैप्टर नोन एज मैकेनिकल प्रॉपर्टीज, देन थिंग्स विल बिकम मोर क्लियर. Brittle means the materials which cannot be shaped by applying mechanical force. Since here both of the atoms are holding together, so it is not possible to displace any one atom without breaking bond, and hence it is not possible to change the shape, and that's why I am saying it is a brittle material. So if you, I hope you belong from ECR electrical background. दस जैन को ज्वाइन किया, फिर भी 2 मेजर सब्जेक्ट बाकी हैं. बीच में बहुत छुट्टी रही क्या, पता नहीं कैसे. चलो खैर, ये सब ग्रीवांसेस मुझसे करने की जरूरत नहीं. टॉक टू द मैनेजमेंट. मैकेनिकल के व्यक्ति हो एंड स्टिल यू आर नॉट एबल टू गेट अबाउट द ब्रिटलनेस. व्हाट आर ब्रिटल मटेरियल्स? those materials which lack ductility. Ductility means ability to deform plastically. When you apply tensile stress, then the material should be deformed, right? Here, if you apply tensile stress, let us suppose you apply tensile stress, these bonds are holding each other very strongly. So it is not possible to dislocate these atoms. And if dislocation is not possible, then ductility cannot come into the picture. And if ductility cannot come into the picture, then lack of ductility is known as brittleness. मुझे तो लगा आप इसी इलेक्ट्रिकल वाले होंगे तो मैकेनिकल प्रॉपर्टी में समझाएंगे, कैसे, मतलब ऐसी बेवकूफ़ी आपसे. Did you get it or not, Ritvik? Since both of the atoms are holding each other strongly, bond is very strong, so it is not easy to displace the atoms. And if atoms cannot be displaced, they cannot be dislocated, then changing shape would not be possible. Shall we go ahead? Right. Go for the next bonding. That is covalent bond. Covalent bond. Let us suppose we have two chlorine atoms. Chlorine atomic number is 17. So the electronic configuration is something like this: 2, 8, 7. Suppose we have one chlorine atom. So it has 3 orbits. Cl. First orbit, second orbit, third orbit. In the first orbit you are having 2 electrons. In the second orbit you are having 8 electrons. In the third orbit you are having 7 electrons. Now suppose you are having another chlorine in its vicinity. You have another chlorine atom. This is chlorine. This is chlorine. This chlorine will also have 17 electrons. 2 in the first orbit, then second orbit 8, sorry, then third orbit 1, 2, 3, 4, 5, 6. Samriddhi Shah is saying that the crystal in which atoms are chemically highly inactive and they do not form compounds with other atoms. Answer is ionic crystal. No dear, atoms are highly active, that's why they are making compound in the ionic. In ionic crystal what are atoms? Sodium and chlorine. They are active and that's why they bonded, and since they bonded, so they make a compound that is NaCl. How can you treat them inactive? कुछ भी. आइए. Now suppose if you are having these two chlorine atoms, none of them is ready to give up its electron. So there is no possibility of making cation. And if cation is not formed, then there is no possibility of forming ionic bond. Because for ionic bond, both cations and anions are required. So how can bonding take place? Bonding can take place if both of them share 1 electrons. So octet of this atom will get completed as well as this atom will get completed. They will become stable. So by sharing up electrons, if octet is being completed, then such kind of bonding is known as covalent bonding. So covalent bond is formed by sharing up electron between the atoms. Now my dear friend, since two atoms are sharing, so the bond is in between these two atoms. It cannot be strong in all the directions. Let us suppose you have chlorine and chlorine. So they are sharing, so electrons are only in this direction. You cannot have in this direction or in this direction or in this direction. So the bond cannot be equally strong in all the directions. Instead, it would be strong in only in the direction in which they are sharing the electrons. So covalent bonds are directional bonds. They are the directional bond. That's why you will find in some of the covalent bonds angle, because sharing would take place at certain angle, then the bond would be formed in that angle only. And that is the reason you find carbon-carbon bond, which is covalent bond, that is 109.8 degree. So most of the covalent bonds has certain angle, because the sharing is taking place in certain orientation, in certain direction. So they have the directional nature of the bond. Bond cannot be equally strong in all the directions. So we can have few points here. The first point is covalent bond is formed by covalent bond is formed by sharing of electrons, by sharing of electrons. Covalent bond is formed by sharing of electrons. Next point, covalent bond is formed by sharing of electron, पहला पॉइंट. दूसरा पॉइंट होगा कि covalent bond is directional bond. Covalent bond is directional bond. Directional bond. Now my dear friend, what are the elements which will make covalent bonds? Chlorine, chlorine. Similarly, hydrogen will also make covalent bond, because hydrogen is having one electron. It needs two electrons to become stable, because it has only first orbit, so it will share with the neighboring atom. So hydrogen will also make a covalent bond. So basically most of the non-metallic elements, so which are having sufficient electrons in the outermost orbit, so that by sharing electrons they can complete their octet, they are making the covalent bond. Have a look in the periodic table. In the periodic table we are having this: first, second, third, fourth, fifth, sixth, seventh and eighth. So you are having hydrogen, you are having helium, lithium, sodium, potassium, beryllium, magnesium, calcium, boron, aluminium, gallium, carbon, silicon, germanium, nitrogen, phosphorus, arsenic, oxygen, sulfur, selenium, fluorine, chlorine, bromine, neon, argon, krypton, etc. These 8th group elements are chemically inactive. They are the chemically inactive atom. अभी कोई पूछ रहा था chemically inactive atoms के बारे में. All other atoms are chemically active except 8th group. 8th group has their octet complete, so they are the chemically inactive atoms. Remaining all the atoms are chemically active, right? Now you see, hydrogen can make a covalent bond, but sodium cannot make, because sodium has only one electron. So if it will share with the neighboring sodium, it will share only one more. So 1 plus 1, 2, octet is not complete. To complete the octet, there should be 8 electrons. So this sodium and this all have not tendency to complete, but carbon can, because carbon has 4 electrons. So neighboring carbon 4, 4 plus 4 is 8. Nitrogen 3, 3, oxygen 2, 2 and chlorine 1, 1. So these all are mostly non-metallic elements. They are able to form the covalent bonds. There is one more possibility. Suppose hydrogen wants to make a bond with chlorine. So chlorine wants 1 electron, hydrogen also wants 1 electron. So hydrogen will never give up its electron like sodium. Sodium has given up because sodium does not want electron, but hydrogen want electron. So in between hydrogen and chlorine, there would be a bonding, that is by sharing of electron. This bonding is by sharing of electron. Chlorine will share its one electron and hydrogen will also share its one electron. And by sharing one electron, they will make a covalent bond. But there is a fundamental difference between the covalent bond of hydrogen-hydrogen, yeah, chlorine-chlorine, between two identical atoms and two different atoms. You see here, the bonding pair electron is attracted by both of the nucleuses. You see here, both nucleuses attract these two electrons. These two electrons are attracted by this nucleus as well as this nucleus. Both of the nucleuses are equally strong. So bonding pair electron will lie between both of the nucleuses. So it will be shared by these two equally. This electron is neither inclined to this and nor inclined to this. It is known as perfect covalent bond, ideal covalent bond. But here you see in case of hydrogen chloride, hydrogen nucleus has 1 proton and chlorine nucleus has 17 proton. So when we see the bonding pair electron, it is more attracted by the chlorine and less towards hydrogen, because only 1 proton is attracting and here 17 protons are attracting. Here the nucleus attraction force is very high as comparison to this. So although sharing is taking place, but chlorine is having most of the time the electron and hydrogen less time. So we can say that in HCl, chlorine is relatively negative, partial negative, and hydrogen is relatively positive. Partial charges are not the physical charge. Electron has not transferred fully from hydrogen to chlorine. It is being shared between both of them. But partial charge means this charge which is shared between these two, that is having most of the time with chlorine, less towards hydrogen. So chlorine is relatively negative as comparison to the hydrogen. Partial ही सही, but still this bond has some ionic character. So basically this bond is ionic plus covalent, partial ionic plus partial covalent. Here two opposite poles are created, one positive pole and another negative pole. So it is known as polar covalent bond. Polar covalent bond. These polar covalent bonds have partial ionic character also. So percentage ionic character in a polar covalent bond, percentage ionic character is 100, 1 minus e to the power minus 0.25 xa minus xb का whole square. This is percentage ionic character. ये percentage ionic character है, where xa minus xb is electronegativity difference between atoms. Electronegativity difference between atoms. Between atoms. It is electronegativity difference between atoms. Suppose both are same atoms, hydrogen, hydrogen, then xa minus xb is 0. And if it is 0, e to the power 0, 1, 1 minus 1, 0, ionic character 0, pure covalent bond. But if they are two different atoms, then they will have certain electronegativity. And if they have certain electronegativity difference, electronegativity means ability to attract the bonding electron. So if there is certain electronegativity difference, then there would be some ionic character definitely. So such bonds which are having ionic as well as covalent both character, they are known as polar covalent bonds. Here you see, if xa minus xb is greater than or equal to 2, ionic bond is formed. Ionic bond is formed. यदि electronegativity का difference 2 से बड़ा हो गया, then ionic bond would be formed. How? You see, 2 square is 4, 0.25 into 4 is 1, e to the power minus 1 is 0.37, 1 minus 0.37 is 0.63. So 63% ionic character. Means if the ionic character is greater than 50%, then the second atom has very high ability to attract electron. So this will snatch electron from the first atom. Now sharing will not take place and ionic bond will be formed. But if the ionic character is less than 50%, then sharing will take place and it would be the partial ionic plus partial covalent, that is known as polar covalent bond. But there is an exception to this. Carbon and hydrogen, although they are different elements, they also form covalent bond. Hydrogen shares 1 electron and carbon need 4, so 4 hydrogens here. This is non-polar covalent bond. This is non-polar covalent bond. No pole is created. It is perfect pure covalent bond. Why it is pure covalent bond? Because the electronegativity difference of carbon and hydrogen is almost 0. Hydrogen has only 1 electron. It is not able to decide whether it should leave electron or it should take. So neither it is positive nor it is negative. Similarly, carbon has 4 electrons, so it is made of the periodic table. Left of carbon, electropositive elements. Right of carbon, electronegative elements. Carbon is unable to decide whether it should go for electropositive or it should go for electronegative. So it is having almost 0 electronegativity, and hence the difference of electronegativity between these two atoms is negligible, and that's why although they are different atoms, still they form the non-polar covalent bond. Means there is no pole formation, that is pure covalent bond. So this way we can classify the covalent bonds in 2 broad categories. What are those categories? The covalent bonds can be covalent bond. First is non-polar covalent bond, basically the pure covalent bond, non-polar covalent bond, and the second is pure covalent bond, polar covalent bond, not pure, polar covalent bond. Here the bond is formed between identical element. Bond is formed between identical elements. एग्जाम्पल के तौर पर H2, Cl2, etc. Bond is purely covalent. Here bond is formed between dissimilar elements. एग्जाम्पल के तौर पर HCl, H2O, इसीलिए H2O को पोलर सॉल्वेंट कहते हैं, etc. Bond has partial ionic character also. Bond has partial ionic character also. Bond has partial ionic character also. Bond के पास में partial ionic character भी है. So this is covalent bond. पहले इतना लिख लो, फिर आगे कुछ बातें करते हैं. Chlorine will never form ionic until and unless it do not get any metallic elements. Only chlorine are not going to form ionic bond. Raghav, chlorine will form ionic bond only if it get any metallic element. रुचि जी कह रही केमिस्ट्री की यही प्रॉब्लम है कि एक्सेप्शंस होते। नहीं नहीं बेटा, केमिस्ट्री की प्रॉब्लम नहीं है, हमारे साइंस की अंडरस्टैंडिंग की प्रॉब्लम है। We as a scientist and engineers are not able to understand, and that's why we say it exception। जब हमको समझ में आ जाता है तो फिर हमें वो एक्सेप्शन नहीं लगता। Since we are not able to understand, so we say it exception। क्योंकि अभी साइंस बहुत कुछ जान नहीं पाई, अभी तो बहुत कुछ दुनिया में जानना बाकी है। Ashi Sharma, identical means they should have zero electronegativity difference. Like carbon and hydrogen both are identical, right? They should have electronegativity difference 0. Mostly when both atoms are same, then they will definitely have electronegativity difference 0, but identical means they should have electronegativity difference 0. Done? Yes, there. The electron cloud will be more inclined towards the element having higher electronegativity. Basically, electronegativity is measured in terms of unit of energy. This is average of ionization potential energy and plus electron affinity. So, average of ionization potential energy and electron affinity, that is known as electronegativity, not required for this course. Please have a look here. Do it quickly. Right bottom side is shown here, please see it. Hari Krishna Prasad. Here also you see there is no free electron. So, generally they would be insulated. All the electrons are participating in the bond formation. So, you do not have free electrons. So, generally these materials are insulated. But few covalent compounds make very weak bond. So, that bond can be easily broken by the room temperature, and hence they may behave like semiconductor, like silicon or germanium. They are covalent compound and at room temperature they may behave like semiconductor. So, we can say that in general most of the covalent compounds are insulated, but there can be few which can be treated like semiconductors or weak conductors of electricity, right. First of all, covalent bonds can be very strong as in diamond, and they can be very weak as in bismuth. So, they have very huge variation. They can be very strong and they can be very weak, because it depends upon sharing. If sharing is so perfect, that they are making stable each other up to very high extent, then the bond would be very strong. Like carbon covalent bond is very strong. Carbon makes sp3 hybridization, and because of which its bonding energy becomes very high, its potential energy goes very down, and this way carbon covalent bonds are very stronger. But other elements are not able to make such kind of bonds, so they may have weaker bonds. So you can write one sentence here. Covalent bonds may be very strong, bonds may be very strong, covalent bonds may be very strong, as in diamond, as in diamond, as in diamond, and has a very high melting temperature, and has a very high melting temperature. Generally melting temperature is greater than 3550 degrees centigrade for the diamond. Or they may be very weak, or they may be very weak, may be very weak, as in bismuth, as in bismuth, which melts at about 270 degrees centigrade. So they can be very strong, they can be very weak, but in general most of the covalent bonds are weaker than the ionic bond, although there are few exceptions, like the bond in diamond is very strong, that can be the exception, but in general most of the covalent bonds are weaker than the ionic bond. CH4 is non-polar covalent bond. I am clearly telling you, कितनी बार बताएं एक ही चीज को, साफ साफ लिखा हुआ CH4 is non-polar. रीजन भी समझाया कि कार्बन और हाइड्रोजन दोनों के बीच इलेक्ट्रोनेगेटिविटी डिफरेंस लगभग 0 है. बाकी generally when there are two different atoms they make polar covalent bond, but carbon and hydrogen are not able to make polar covalent bond because their electronegativity difference is almost 0, so they are the non-polar compounds. एक ही चीज को सुन के कैसे कोई गलत कर सकता है? प्लीज नोट डाउन. Nandini ji, you may be writing very slowly because most of the people when comment they have written, then I proceed for the next discussion. So if you are not able to write, it means you are writing very slowly. Please try to increase your speed a little bit more. Alok, you are wrong. Fluorine has higher electronegativity than chlorine. आपने कहीं उल्टा पढ़ लिया है. Now, my dear friend, these covalent compounds can be solid, liquid or gas, कुछ भी. H2 is gas, H2O is liquid, HCl is liquid, diamond is solid. All these are what? Covalent compounds. So covalent compounds can be solid, liquid or gases. ये कुछ भी हो सकते हैं. Covalent compounds can be solid, liquid or gas. They can be solid, liquid or gas. Covalent bonds are directional bond. So because of directional bond, suppose the bond is like this, directional bond. So you cannot have high packing efficiency because in this space you will not have any atom. So this space will remain empty. It means what? In a given volume less number of atoms can be packed. So they have poor packing efficiency. In the next chapter, I will mathematically prove it. I will show you the packing efficiency. But here you write covalent solids, covalent solids such as diamond, do not form closed pack structure. Closed pack structure means in a given volume they have very less number of atoms. Generally, covalent compounds are insulators. Generally, covalent compounds are insulators, but there are some which may be weak conductors. There are some which may be weak conductors, Again, two atoms are holding each other, so displacing atom is not possible. So if dislocation of atoms is not possible, then the material will be brittle. So covalent solids are brittle materials. Covalent solids are also brittle material. They are also brittle material. Now the next point is, if there is a pure covalent solid like diamond, it cannot be dissolved into the water. Because water is a polar solvent, so it has H plus and O minus. So it can dissolve only the ionic compounds. But if it is a pure covalent compound, then there should not be any poles. And if there are not poles, then it cannot be dissolved. So covalent solids cannot be dissolved into the liquid, or they are insoluble in the water. Not liquid, precisely speaking, water. So covalent solids are compounds are insoluble, means not soluble, insoluble in water. They are not soluble in water, or they are not soluble in polar solvent. Please note down all these points. लिख लीजिए. Done? जी आशीष सिंह, फर्स्ट चैप्टर ही चल रहा है, थोड़ा बड़ा चैप्टर है, बेसिक चैप्टर है. एक्चुअली फर्स्ट चैप्टर में बहुत सारी चीज़ें पढ़ ले रहे हैं, सो आगे नहीं पढ़ना पड़ेगा. जैसे जब हम सेरेमिक पढ़ेंगे, आयनिक बॉन्ड पढ़ चुके हैं, सो प्रॉपर्टीज फटाफट लिखते चलेंगे, वहाँ एक्सप्लेन करने की ज़रूरत नहीं पड़ेगी. दैट्स व्हाई फर्स्ट चैप्टर इज टेकिंग टू मच टाइम. Because most of the properties of the material are direct consequence of their bonding. Yes, Rohit, polar are ionic solvent, basically partial ionic materials, and when there is ionic character, then it can be soluble. But if I am writing covalent, it means I am ignoring the ionic character. So higher the ionic character, more will be the solubility. Lesser the ionic character, lesser will be the solubility. That would be the correct statement, right? Let us go for the next point. So it is covalent compound. Here I have to discuss a small theory, that is molecular orbital theory, how molecules are formed. Although I am explaining it by taking example of hydrogen, but that is equally valid for the partial ionic characters also, that is valid for the ionic characters also, that is valid for HCl, H2O and everyone. So, but for explanation purpose I am taking a pure covalent bond. Conclusions would be valid for ionic, covalent, polar covalent, सभी के लिए valid रहेंगे. So let us put molecular orbital theory. Molecular orbital theory. Consider a hydrogen molecule. Consider a hydrogen molecule. H 1s1 electronic configuration, 1s1 electronic configuration. Let us suppose you have two hydrogen atoms, this one and this one. Initially I am assuming they are far away from each other. So if I plot their energy, this is energy bottom to top. So here atomic orbital, right? This is atomic orbital of the first atom. So the first atom will have certain energy, this 1s will have certain energy. Let us suppose this is the value of energy that you can easily calculate, and the electron is here, that you can calculate minus 13.56 Z square by N square electron volt, that formula I have given. So it is the energy of electron in the first atom. Second atom is exactly same as the first. So second atom electron will also have same energy. So if you plot the energy of the second orbital, it will also be exactly same. Here 1s2. Now I am bringing these two atoms closer. When they come closer, two types of forces will start to work on them. First, attraction, which is trying to keep them together, and repulsion. Sorry. Attraction, there will be two types of forces. Attraction, which is trying to bring them together and trying to make a bond. And repulsion, which is trying to repel them away, right? So let us consider first attraction. Forget about the repulsion. So this attraction is trying to keep these two atoms together. Basically we can say that this nucleus is attracting this electron, this nucleus is attracting this electron. So if these are the nucleuses, most of the time electrons would be revolving around both of the nucleuses. ऐसा लग रहा है कि दोनों को ऐड करके बन गया है. So it is 1s and it is 1s. I am neglecting repulsion, I am considering just the attraction. It is known as sigma ns. If you recall, I told you that if electron is very close to the nucleus, energy is minimum, and if it is away from the nucleus, energy would be maximum. Here you see, my dear friend, any electron is attracted by two nucleus. So effective positive charge is at this point, and all the electrons will be very closer to the effective positive charge. And if electrons are coming closer to the positive charge, then energy should come down. So as they are coming closer, the energy is decreasing. The energy is decreasing. It is decreasing. And at some point of time, the energy will become constant. This is sigma 1s. So sigma 1s is having less energy than 1s, because in 1s only one nucleus is attracting electron, whereas in sigma 1s two nucleuses are attracting electron. So attracting force is more powerful, and hence electron is coming closer to the nucleus, so energy should come down. As of now, I am neglecting repulsion. Now let us consider the repulsion. Repulsion when take place, so nucleus will repel each other. These nucleuses will repel each other, so they will go away. And these electrons, this electron will repel to this electron, so no electron at this side. This will go this side. This will repel to this, so this will go this side. They will not come in between the region. So effective positive charge would be somewhere here, and electrons are far away from the effective positive charge. And if the distance of electron from the effective charge increases, then the energy should increase. So as comparison to individual atom, now the energy will increase. It is known as sigma 1s star. So this orbital is known as sigma 1s star. This is due to the repulsion. Repulsion is considered like subtraction, and attraction is considered like addition. Now my dear friend, you see, when two atomic orbitals are coming closer to each other, two molecular orbitals are formed. One is sigma 1s and another is sigma star 1s. The first molecular orbital is trying to decrease the energy of individual atoms. If energy is decreasing, stability will increase. Stability will increase, it means bonding will happen. So this molecular orbital is trying to make the bond, because it is trying to decrease the energy. So it is known as bonding molecular orbital. It is known as bonding molecular orbital. But here you see, this molecular orbital is increasing the energy, and if it is increasing the energy, it means it is trying to make them unstable, and if it is trying to make them unstable, it means it is opposing the bonding. So it is known as anti-bonding molecular orbital. It is known as anti-bonding molecular orbital. Anti-bonding molecular orbital. Now, when the bond would be formed, you will have two electrons, 1 plus 1, and these two electrons will be filled in the molecular orbitals. So first electron go here, second electron will also go here, because at one state you can have two electrons, one anti-clockwise and other clockwise. If there would have been third electron, it would be going to this, but there is no third electron, so there is no possibility of going to upside. Now you see, since now electrons are at this state, so molecule H2 has less energy than hydrogen atom H, and if the potential energy is less, then stability will be more, and that is the reason hydrogen is not stable in the environment and H2 molecule is stable. My dear friend, in order to become the stable structure, the electrons in the bonding molecular orbital must always be greater than electrons in the anti-bonding, because anti-bonding is trying to unstable, trying to destabilize, and if number of electrons in anti-bonding will become greater, then the bond will become unstable. Even there should not be equal electrons, because if equal electrons, then anti-bonding and bonding will cancel each other and no bonding will take place, only atom will remain stable. So for stable molecular structure, number of electrons in bonding molecular orbital must always be greater than the number of electrons in anti-bonding molecular orbital, so that overall energy of molecule will remain less as comparison to energy of the atom, and if energy is less, then the molecule will be stable, it means bond will be formed. So I can dictate this in a simple word कि for stable bonding, number of electrons in bonding molecular orbital must always be greater than the number of electrons in anti-bonding molecular orbital, For stable bonding, number of electrons in bonding molecular orbital must always be greater than the number of electrons in anti-bonding molecular orbital. Please note down this. This is true for ionic as well as for covalent. For any kind of bonding, the bonding energy, the potential energy should be minimum as comparison to the individual atoms, and that is possible only if the number of electrons in bonding molecular orbital are greater than the number of electrons in anti-bonding molecular orbital. Do it quickly. Noted? Good. Now let's move on towards next type of bonding, that is metallic bond. Metallic bond. Obviously the name is suggesting that it would be formed between the metallic atoms. Metallic atom, for example, sodium. Sodium has atomic number 11, so it has 2, 8 and 1 electron. This sodium is always having tendency to give up this outermost orbit electron, because if it give up this electron, then this become outer orbit and it will have stable configuration. So all these metallic atoms will have tendency to give up their electrons. Suppose they get any non-metallic atom in their vicinity, then they will make ionic bond. But if they do not get non-metallic atom in their vicinity, then they cannot form ionic bond. So how can they form bond with themselves? Let us suppose all are sodium atoms. अब सारी के सारे अगर सोडियम एटम है तो सभी की टेंडेंसी क्या है? to give up the electrons. So let us suppose we are having all the sodium atoms. These all are sodium atoms. Sodium atoms. These are sodium atoms. All of these atoms have tendency to give up outermost orbit electron. So they have given up their outermost orbit electrons. So basically now in this whole region you have a pool of electrons. Pool of electrons, which is known as electron cloud. In this electron cloud, you see, when the electrons are given up by these atoms, they will become cation. So all of them has become cations. They become cation. All of them has become cations. These are cations. Now you see, my dear friend, these cations are positive charges and this pool of electron is negative charge. So this negative charge, that is pool of electron, will attract these cations. So this will not let them go away. So as a whole, this cation will not leave the electron cloud, and these electron clouds are not going to leave these cations, so the structure will remain stable. So basically here these cations are held together by this electron cloud. Now you see, this cation and cation will repel each other, but in between them there is an electron cloud. This is the electron cloud, negative charge. So this repulsion force between the neighboring cations is overcome by the electron cloud. Basically electron cloud is working like a glue to stick them together. ये glue की तरह काम कर रहा है जो उनको चिपका करके रखा हुआ है. Such kind of bonding is known as metallic bonding, where each atom shares its outermost orbit electron, and hence a common pool of electron is prepared, that is known as electron cloud, and each cation is attracted, stick together in this electron cloud. My dear friend, you see here, all these electrons are free to move anywhere in the material. This electron is being attracted by this atom, then it will be attracted by this atom, will be attracted by this, 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 will be attracted by this. Means these electrons are free to move anywhere in the pool of the electrons. Such electrons which are free to move anywhere in the material, they are known as free electrons. In the previous two cases, the electrons which were participated in the bond formation, they were not free. They were bound between the two atoms. Here, electron is not bound between two atoms. Instead, it is free to move anywhere in the material. So you have abundance of free electrons, and because of this abundance of free electrons, these materials are very good conductor of electricity. One more thing, suppose you have a covalent bond and you increase the temperature, then covalent bond would be broken, some free electrons will be created. So in covalent compounds, by increasing temperature, you can increase the number of free electrons. By breaking the covalent bonds, you can make the electrons free, and you will have more number of free electrons with increase in temperature. Here it's not possible. Why? All the electrons are already free. So even if you increase the temperature, there is no possibility of getting more free electrons. So these materials are having large number of free electrons at any temperature, and all the outer orbits electrons are participating in the bond formation. They are in the electron cloud, and all the electrons of electron cloud are free. So even if you increase the temperature, you will not have any possibility to getting more electrons. So in the metals, because of this metallic bonding, with increase in temperature, there is no increase in number of free electrons. Whereas I will teach you semiconductor and I will tell you that semiconductors are covalent compounds. So in covalent compounds at low temperatures all the bonds are formed, you will have negligible free electron, but when you increase the temperature bond will be broken, the number of free electron will increase. It's not the case in the metallic bonding. In the metallic bonding all the electrons are free to move anywhere in the material. यहाँ जो electron bonding करा रहा वही free भी है, गंगाधर ही शक्तिमान है. So here the same electron is participating in the bonding as well as it is free. So both are the same things. This gives a very good character to these materials. You see, if you apply any force, these atoms are not holding to this atom. In the previous case, neighboring atoms were holding these atoms, so movement of this atom was not possible. But here this atom is bound by the cloud, not with these atoms. So when you apply any force, this atom can be displaced. And there is no effective bond breaking, because here it was with the cloud, here it will make bond with the cloud. So atom movement is possible within the cloud, and when atom dislocates, the shape of material changes. It means these materials are plastically deformable. They can be drawn into the wires, hence they have ductility. They can be converted into the sheets, hence they have malleability. So these are not the brittle materials, these are ductile and malleable materials. Why they are ductile? Because atom movement within the cloud is possible by applying mechanical force, whereas it was not possible in the previous case, because in the previous case the neighbors were holding strongly. Here neighbors are not holding. इसके जाने से इस पर कोई फर्क नहीं पड़ेगा, ये यहाँ से हटे, they are bound with the cloud, this is also bound with the cloud, this is also bound with the cloud. So even if this atom is going, this atom will never have any impact in its stability. So atom movement is possible, and that is the reason why these materials are ductile and malleable. These metals are shiny in appearance, they have luster, chamak. These materials have luster. Why? Because if the electron is bound and you supply any optical energy, if energy is sufficient to break the bond, then only the atom will accept energy, otherwise energy will not be accepted, it will get transmitted. How can we see anything? Some light is falling on the material, light is absorbed by the material, and then if the material reflects back the light, then we can see it. So as much as light is reflected back, that much shiny will be the material. Here, since the electrons are free to move anywhere in the material, and free electrons can accept any amount of energy, so even the weak light signal goes from the eyes, that light signal can be absorbed by these electrons. When the electrons absorb light energy, they get excited. Any electron cannot remain in excited state for long duration, so they return back within a nanosecond. When they return back, they release the energy, and that energy comes to our eyes, and that is why these materials are lustrous, shiny. So the metals are shiny, metals are lustrous because of this electron cloud. So this electron cloud gives metals some out of the box characteristics which were not possible with the previous two types of bonding, and that makes metals a very useful material, and that is the reason why we use metals in so many places and they are used so frequently. Again, the melting point would be high, density would be high. Density, why density is high? Because cations, when they will leave their electron, effectively they had become cation. Cations are very smaller in size, so they will be densely packed. Small atoms can be packed closely together, so they will be densely packed, and if they are densely packed, mass per unit volume would be high, so density would be high. Non-directional bond hai. It's not like that there is a sharing between the two atoms, no. In any direction you see the bond strength is equal, so it is a non-directional bond, and if the non-directional bond, then still packing efficiency would be very high. So these are the few things related with the metallic bonding. आप इस फिगर को बना लो, कुछ डिक्टेट करूंगा. Done? Please make the diagram so that I can dictate few points. Here I would be dictating few things. Quickly do it. Done? Right, please. बिल्कुल बेटा, आप कह सकते हो। किसने लिखा? प्रतीक, एकदम सही हो आप, क्योंकि ये नेबरिंग एटम्स के साथ में मेटालिक बॉन्डिंग ही बना सकता है, सो इट विल बी एग्जिस्टिंग लाइक Na+ इन द स्ट्रक्चर. राइट, प्लीज नोट डाउन फ्यू पॉइंट्स. हियर प्लीज स्टार्ट राइटिंग. हियर मैं लिखूंगा नहीं, आई एम डिक्टेटिंग, प्लीज. हियर valence electrons are not bound. Here valence electrons are not bound to any particular atom in the solid. Adit abhi likho, Adit Shankar Sharma. After this heading I will show for 5 seconds. Here valence electrons are not bound. Valence electrons are not bound to any particular atom in the solid. To any particular atom in the solid. And are more or less free to move, and are more or less free to move throughout entire metal. Free to move throughout entire metal. More or less free to move throughout entire metal. Full stop. They may be thought of as belonging to the metal. They may be thought of as belonging to the metal as a whole, W H O L E, as a whole, or forming a sea of electrons, या इलेक्ट्रॉन क्लाउड लिख लो, or forming electron cloud, or forming electron cloud. Electron cloud. Full stop. The remaining non-valence electrons, the remaining non-valence electrons, non-valence electrons, the remaining non-valence electrons, non-valence electrons and atomic nucleus forms cations, forms cations, forms cations. Full stop. Forms cation. Full stop. The free electrons shield, SHIELD, free electrons shield, SHIELD, shield cations from mutual repulsive force, cations from mutual repulsive force, mutual repulsive force. In addition, these free electron cloud, in addition, these free electron cloud act as a glue, act as a glue to hold cations, act as a glue to hold cations. To hold cations. मैंने बोला देखें, the free electron sealed, SHIELD, sealed the cations from mutual repulsive force, from mutual repulsive force. The free electrons shield the cations from mutual repulsive force. In addition, these free electron cloud, act as a glue, act as a glue to hold the cations, to hold the cations. Full stop. Next point. Metallic bond is non-directional. Metallic bond is non-directional. Is non-directional. Full stop. Next point. Bonding may be very weak or strong. Bonding may be very weak, or strong, or strong, or strong. Bonding energies range from 1 68 kilojoule per mole, 68 kilojoule per mole फॉर मरकरी, सबसे वीक मेटेलिक बॉन्ड इसी में होता है फॉर मरकरी, एंड 850 kilojoule per mole for tungsten, and 850 kilojoule per mole for tungsten, for tungsten. So in general, you see, the best metallic bond is in tungsten and the bonding energy is how much? 850. Whereas in ionic bonding I told you 1500. So ionic bond is far stronger than the metallic bond. So strongest one ionic, then covalent, and then metallic. In general, few compounds may be exception like diamond, etc. Their respective melting temperature, their respective melting temperature is -39 degree centigrade, and mercury के लिए -39 degree centigrade and 3410 degree centigrade for tungsten. So the stronger the bond and better will be the melting point, yeah, higher will be the melting point. Few characters of these materials. So high electrical and thermal conductivity, high electrical and thermal conductivity because they have abundance of free electrons. Second, metals have luster, metals have luster. Luster means chamak, shine. So they have luster or shine. Then next one is high density, malleability and ductility, malleability and ductility. This is all about the metallic bonding. Please do it quickly. Yes, that's why mercury is a liquid at the room temperature, because it has very weak metallic bond. It melts at -39 degrees centigrade. Below that it will also become solid. Someone said to show ionic bond, something in ionic bond is left. This is ionic bond. Please, if you want to take the picture, please take it. We started from here, then we went here, then we went here, here, like this. So these were the three primary bonds. Strongest one ionic, then covalent, and then metallic. Now we would be moving towards secondary bond. Secondary bonds are formed in the molecules. So they are known as molecular bonds. If there is primary bond dominant, then it will restrict the formation of secondary bond. Like you see, in whole sodium, there are primary bonds. So if there is a possibility of making primary bond in whole crystal, no secondary bond would be formed. Like in silicon, covalent, covalent, silicon, like this. So whole crystal is because of primary bonds. So if the whole material can be because of primary bonds, then there is no possibility of secondary bond. But suppose HCl, right? Now this Cl will not make bond with any other H. So this HCl. Now these two molecules, how they would be connected? They can be connected like del minus and del plus and del minus. They cannot share, they cannot transfer charge, there is no possibility of making any other bond. So if any kind of bond is formed between these two molecules, that is known as secondary bond. That is known as secondary bond. And this weak force between these two dipoles, one dipole is this and one dipole is this. So the weak force between these two dipoles is known as van der Waals force. Since van der Waals force is because of partial charges, and partial charges are never a stable one, they keep on fluctuating. So this force can never be a stable one. That is the reason it is considered to be the weakest force in nature. This van der Waals force is weakest in the nature. And if the force is weakest, then bond would be weaker. So secondary bonds are the weakest bond. Secondary bonds are also known as molecular bonds because they are formed in the molecules. So let's put the heading, and that is secondary bond. Secondary bond. First point, intermolecular bond. It is formed between the molecules. Intermolecular bond. Bond is formed due to van der Waals force. So it is because of van der Waals force. Van der Waals force are weak, so this bond is very weak, and if it is weak, then it is unstable. Any secondary bond can never be stronger than any primary bond. Even the strongest secondary bond will be weaker than the weakest primary bond. Please note down it, then we would be categorized. No, your Pratik, your assertion is wrong. Actually, the stability will come when attractive and repulsive forces will cancel each other. You can say like this, because of attractive forces, potential energy will try to go down. So if potential energy becomes a minimum, then the bonding is becoming stable. I cannot say the point which you are raising, that's not correct. The net force should be equal to 0, then only the bond can be formed. If it is attractive force, let us suppose you are saying that the attractive force is greater. So if the attractive force is greater, then they will keep on attracting each other. So they will intermingle with each other, they will become one. Why should they stay? They will stay only if there is some force to balance that attractive force also. So in terms of force, that's why I didn't explain. I am explaining in terms of energy. The reason behind this is force must be balanced in order to become stable. Otherwise, if attractive is stronger, they will keep on attracting each other, they will not stop. And if the repulsive is stronger, then they will keep on repelling each other, they will never stop. And in order to make a bond, they should stop at a point and they should be stable at that point, right? Samriddhi, you don't know malleability? Malleability is ability of a material to be converted into sheet by applying compressive force, by applying pressure. So malleability is the ability of a material to be converted into sheet. So when you apply pressure on the material. Let's come back. Now I am writing the first type of secondary bond, that is fluctuating induced dipole bonds. I am not giving much weightage to secondary bonds, so quickly would be finishing them. Fluctuating induced dipole bonds. In order to become secondary bond, to make secondary bond, dipole must be formed. Let us suppose you have inert gas. Suppose you have inert gas molecules. Inert gas molecules means what? Helium, neon, argon, etc. Helium, neon, etc. Yeah, you have non-polar molecules. Non-polar molecules such as H2, Cl2, etc. Non-polar molecules. So in these materials there is no dipole. You see, H and H, there is no dipole. Yeah, helium atom, there is no dipole. It is a single atom, there is no dipole. So how can molecules attract each other? Is there any possibility of attraction of molecules? Yes, there is. Have a look. Suppose you have two helium atoms. This is one helium atom and this is another helium atom. This is the nucleus and this is the nucleus. Electrons are uniformly distributing around the nucleus. Let us suppose I am taking them as still atom. They are quite still, शांत हैं एकदम. So positive charge is here and negative charge is uniformly distributed in a spherical volume. So effective negative charge can be considered at the center. It means no dipole is formed. For dipole, positive and negative charges must have some distance, must have some separation. कोई ये नहीं कंसीडर करने चाहिए कि इलेक्ट्रॉन यहाँ गिर गया. नहीं, इलेक्ट्रॉन इज मूविंग अराउंड. आई एम सेइंग दैट द इफेक्ट ऑफ दैट नेगेटिव चार्ज कैन बी कंसीडर्ड एट द सेंटर ऑफ द स्फीयर. So effective positive and negative charges are at the same point. No dipole is formed. But this is an imaginary situation. In practical reality, this material would be kept at any temperature. Let us suppose room temperature. So because of that temperature, there would be some thermal energy. And due to that thermal energy, these atoms vibrate around their mean position. This is known as atomic vibration, or thermal vibration, or lattice vibration, whatever you say. So when these atoms vibrate around their mean position, so because of vibration, this electron cloud repels this electron cloud, and this nucleus attract this electron cloud. What happens? Because of repulsion of nucleuses will go away and electron clouds will try to come this side. So basically the shape of each molecule will change. Let us suppose electron cloud go like this and nucleus like this. The center of electron cloud suppose comes this side and nucleus this side. Because they are vibrating, so electron clouds will repel. So this is going this side and nucleus is coming this side. So hence positive and negative charges will have certain distance. And when positive and negative charges will have certain distance, so a dipole is formed. Similar type of dipole is formed in other element also. So similar type of dipole will be formed in the neighboring elements. So these dipoles will attract each other. They will attract each other. And the force between them is known as van der Waals force. The force between them is known as van der Waals force. Such kind of secondary bond between the two inert gases, ये है chemically active elements. और इन chemically active elements के बीच का जो bond है वो secondary bond है, जिसे fluctuating induced dipole bond या van der Waals force या van der Waals bond कह रहे हैं. So between the chemically inactive elements like inert gases, we can have only one type of bonding, and that is van der Waals bonding. Yeah, fluctuating induced dipole bond. Here thermal vibration is inducing this dipole, and that is the reason these gases become liquid at low temperatures, and certain below the temperature they may become crystal also. Argon becomes crystal below 4 degrees centigrade. So the crystallization, a liquefaction of these gases, because when you are making crystal, it means these gas atoms are coming closer. When you are making liquid, it means these molecules are coming closer. Then only the liquid can be formed. And to come closer, there must be some force. So what is that force? That force is van der Waals force. So this van der Waals force is responsible for the liquefaction of these gases or solidification of these gases. इस तरह से यदि इनका solidification होता है, so that kind of crystal is known as van der Waals crystal, because this crystal is formed due to the van der Waals bonding, right? Please note down this, and I would like to dictate few points. Then please note down. Thermal vibrations of atoms या molecules, thermal vibrations of molecules, thermal vibrations of molecules can cause to formation of instantaneous and short-lived distortions. Thermal vibrations of atoms can cause instantaneous and short-lived distortions. Resulting in formation of temporary dipoles. Resulting in formation of temporary dipoles. These dipoles attract each other. And form a very weak van der Waal bond. Full stop. The liquefaction यानी लिक्विड बनना, the liquefaction and in some cases the solidification of inert gases is because of this type of bonding. These are the weakest possible bonds. Next point. This one is here both of the atoms were identical, non-polar induced. Let us suppose one is polar and another is non-polar. So polar molecule induced dipole bond. Polar molecule induced dipole bond. Suppose you have HCl. This is polar. It has del minus and it is del plus. And in the vicinity of HCl, you have any non-polar. Let us suppose H and H. Yeah, you have any inert gas molecule like this. So this negative will repel to the electron and attract this. So what will happen? This will have distortion and it will become like this. Here plus and here minus. So this plus and minus, it is a induced dipole. Induced dipole. And what is the reason for inducement of this dipole? This polar molecule. This polar molecule is inducing dipole, polar molecule, and this is non-polar molecule. This is non-polar molecule. So a polar molecule is inducing dipole in the non-polar molecule, and because of this you will have some van der Waals bonding, and that kind of bonding is known as polar molecule induced dipole bond. Polar molecule induced dipole bond. It would be relatively stronger than the previous one, but not very stronger. Why relatively stronger? Because here you have a permanent dipole which is pushing, not the vibration is pushing, instead the permanent dipole is creating this bond. So it is relatively better than the previous one, but is still not very strong. So you can write here. Here you can write, polar molecules can also induce, polar molecules can also induce, please I am dictating, you write it, polar molecules can also induce dipoles in adjacent non-polar molecules. Dipoles in adjacent non-polar molecules, and a bond will be formed, due to attraction of dipoles, full stop. The strength of this bond will be greater. The strength of this bond will be greater. The strength of this bond will be greater than for fluctuating induced dipole bonds. The strength of this bond will be greater than for fluctuating induced dipole bond. Next one. Permanent dipole bonds. These will be the stronger in all these secondary bonds. Permanent dipole bonds. This will be found in polar compounds, yeah, polar molecules में, polar molecules. Here we have permanent dipoles, like you have HCl and you have HCl, right? So del minus and del plus and del minus, these molecules will attract each other. One molecule is this and one molecule is this. So these molecules attract each other, and this is known as permanent dipole bond. Dipole bond. This is also van der Waals force. This is nothing but van der Waals force. It is stronger than the previous two, because here you have permanent dipoles, you need not to create the dipoles. Suppose you have three elements, fluorine, oxygen and nitrogen. So del minus and del plus. And suppose the secondary bond is formed with hydrogen, H H. This is del plus this, and this is del plus, and this is del plus. Since these three elements have highest electronegativity in the periodic table, so these del minus would be very strong, and these del plus will make a strong bond. So such strong secondary bonds are known as hydrogen bond. So hydrogen bond is a special case of dipole bond where the bonding is taking place between one fluorine, oxygen, a nitrogen atom of one molecule to the hydrogen atom of another molecule. For example, you see, my dear friend, let us suppose it is HF and it is HF. So you have del minus and you have del plus. You have del minus and you have del plus. So this one is one molecule and this one is another molecule. So this del minus and del plus will attract each other, and this bond is known as hydrogen bond. This is known as hydrogen bond. Similarly, my dear friend, you can see hydrogen bond in the water. HOH. HOH. This is del minus minus, del plus, del plus, del plus, del minus minus, del plus. So the force between this O minus and H, this is hydrogen bond. So hydrogen bonds are strongest one among all the secondary bond, but they are also weaker than the primary bond. They cannot be stronger than the primary bond. So basically hydrogen bond is a special type of permanent dipole bond. Permanent dipole bond where bonding should be between FO and S. इन तीनों में से किसी एक का होना जरूरी है कि और दूसरा हाइड्रोजन, तभी ये बॉन्ड बन पाएगा. ठीक. सो प्लीज यू नोट डाउन फ्यू पॉइंट्स हियर एज वेल. Note down it quickly. Done? Right. इसमें कुछ लिखाने को नहीं है. You can write the bonding energy. सब कुछ बोर्ड पर लिखी गया है. So I'm not wanting to write. Bonding energy हाइड्रोजन में जो होती है, that is 51 kilojoule per mole. So if you compare with the primary bond, it is very small, but among all the secondary bonds, it is a higher one. Bonding energy is approx 51 kilojoule per mole. इसका मतलब हुआ हाइड्रोजन बॉन्ड इज स्ट्रॉन्गेस्ट among all secondary bonds. Hydrogen bond is the strongest among all secondary bonds. secondary bonds, but it is weaker than primary bonds, but it is weaker than primary bonds. It cannot be stronger than the primary bond, it is the weaker than the primary bond. कभी भी कोई भी हाइड्रोजन बॉन्ड या कोई भी सेकेंडरी बॉन्ड किसी भी प्राइमरी बॉन्ड से स्ट्रांग नहीं हो सकता. प्लीज नोट डाउन दिस. Who told Rajanshu you chlorine is more electronegative than nitrogen? You are fundamentally so wrong. ठीक, chlorine is less electronegative than nitrogen. फिर से केमिस्ट्री रिवाइज करें. हाईएस्ट इलेक्ट्रोनेगेटिविटी फ्लोरीन, सेकंड हाईएस्ट ऑक्सीजन, थर्ड हाईएस्ट नाइट्रोजन, देन क्लोरीन. ठीक है, चौथा नंबर है. ऐसा कुछ भी बोल दोगे और मान लिया जाएगा? नो. यस प्रतीक, if there are polar molecules then they will always have polar molecule induced dipole bonds. Done, right. My dear friend, I have to discuss one small thing. Actually there are three rays, alpha, beta and gamma. They are very frequently used in industry for various kind of testing, yet to study the properties of materials. So we need to know about these rays. Basically their comparison is required to be studied. How these rays comes into picture? Let us suppose it is isotope of carbon. It is isotopes of carbon. Yeah, isotopes of hydrogen. Now you see all these atoms of hydrogen are having atomic number 1. It means they have equal number of proton, but atomic weight is different. It means number of neutrons is increasing. Similarly here number of protons is same, but the number of neutrons is increasing. If number of neutrons in the nucleus will increase, nucleus will become unstable. If something is becoming unstable, it will have high energy, so nucleus will have high energy. Nucleus will try to emit this energy in order to achieve stability, and that's why the elements having higher atomic weight, atomic mass, become unstable and they become radioactive. When they become radioactive, their nucleus starts releasing energy, and that energy is released in the form of some particles. Those particles are known as alpha, beta, या gamma. Basically gamma is a ray, not particle. Series of rays is known as particles. So lots of particles are coming, that will become alpha ray. Lots of beta particle are coming, that will become beta ray. Gamma is a ray itself. Although these materials are not the matter of discussion in our subject, we are not going to study radioactive materials. But since we use these alpha, beta, gamma rays in various places, so we should know the character of these rays. So I am directly coming to the heading that is known as comparison of alpha, beta, gamma rays. Comparison of alpha, beta and gamma rays. Comparison of alpha, beta and gamma rays. First of all, let us start discussing alpha rays. Basically alpha particle, series of alpha particle will become alpha rays. Alpha rays. Alpha particle consists of 2 protons and 2 neutrons. So basically it is nothing but active helium nucleus. because helium has 2 proton, 2 neutron and 2 electron. So if you remove the 2 electron, whatever is left, that is helium nucleus, and that helium nucleus is known as alpha particles. So if any radioactive element is emitting alpha particle, it means it is emitting helium nucleus. My dear friend, you see, one proton या one neutron is mass of 1 AMU. So this alpha particle will have mass of 4 AMU. At the atomic level, 4 AMU is very high mass. So this is a very heavy particles. So small radioactive elements are not capable of emitting alpha particle. For example, this hydrogen does not have capability to emit alpha particle. It is having in total 3 AMU mass. How can it emit 4 AMU? So emitters of alpha particle are heavy radioactive elements. Heavy radioactive elements like uranium etc. जिनका atomic mass 230, 235 like that काफी high होता है. So emitters of alpha particles are heavy element because alpha particle itself is a very heavy element. Okay. Now you see, my dear friend, it has 2 protons. 2 protons means 2 Q का positive charge. Q is magnitude of electronic charge. So it has 2 unit charge. Means very high charge. Among all these 3, it will have highest magnitude of charge. So if magnitude of charge is very high, when it will come into contact with any neutral body, it will try to snatch electron. So when it snatches 2 electron, it becomes helium atom and goes away. But this material has become an ion because 2 electrons has gone. So it has capability to ionize the material in its surrounding. This capability is known as ionization potential. And ionization potential will depend upon the magnitude of charge. Since it is having highest magnitude among alpha, beta, gamma, so it will have highest ionization potential in all these 3. ध्यान रहे, कंपैरिजन हम इन्हीं तीनों में कर रहे हैं, किसी और चीज से नहीं कर रहे हैं. So this alpha particle have highest ionization potential. Now move on. Since it is a very heavy particle, so it would be moving with very slow speed. जितना ज्यादा मास बढ़ाते चले जाएंगे, वेलोसिटी क्या हो जाएगी, कम हो जाएगी. It travels almost with 5% speed of light. So it is very slow ray, very slow particle. And if it is very slow, then it cannot penetrate. Why? If anything is very fast, it may easily penetrate. But if it is very slow, then its penetration power will be minimum. So among all these 3, because of very slow speed, alpha particles are having least penetration power. And if they are having least penetration power, so they cannot penetrate even the outer layer of human skin. ये human skin की बाहरी सतह को भी penetrate नहीं कर पाती हैं. इसका मतलब ये नहीं समझना चाहिए कि these are not dangerous. These are very dangerous. They cannot penetrate human skin, but they have capability to ionize the human skin. So they will take the electrons from our body, they will ionize our body. Our body will become unstable. Because in order to become stable, we should remain electrically neutral. So they are very dangerous for us. But they are not able to penetrate through the body. So let us write these points. So first point we can write, alpha particle consists of 2 proton and 2 neutron. Alpha particles consist of 2 protons and 2 neutrons. That is an active helium nucleus and active helium nucleus. Mass of alpha particle is 4 mu. So it is a heavy particle. Hence emitters of alpha particle, मतलब जो emit करेंगे इन्हें, emitters of alpha particle are heavy elements. Heavy elements emitters of alpha particles are heavy elements. These are positively charged particles. These are positively charged particles. These are positively charged particles. Charge is equal to plus 2q. They have हाईएस्ट आयनाइजेशन पोटेंशियल. हाईएस्ट का मतलब इन तीनों में हाईएस्ट आयनाइजेशन पोटेंशियल. आयनाइजेशन पोटेंशियल मीन्स कैपेबिलिटी टू आयनाइज. They have highest ionization potential. They travel with very slow speed. They travel with very slow speed. They have the least penetration power. The least penetration power. They cannot penetrate. They cannot penetrate even the outer layer of human skin. Even the outer layer of human skin. They cannot penetrate even the outer layer of human skin. Please note down. These are the things you need to remember regarding alpha particle. Quickly note it down. Value of bonding energies are not required to memorize Samriddhi. I have given values just to make the comparison clear. Come to the beta particle, beta rays. Quickly, because time is going to be over. In 3 minutes, 2 minutes, we will be doing these two and we'll be ending the class. Beta rays, beta particles. You see, my dear friend, let us suppose this is the nucleus, proton plus neutron, and this nucleus is active. And these are the orbital electrons. I am not talking about any orbital electron. Leave it. It is ordinary electron. Ordinary electron which is moving into the orbit. Forget about it. Right? Suppose this helium nucleus is active. Means it has very high energy. Because of high energy, any neutron is broken. क्योंकि एनर्जी जहां ज्यादा होगी वो तोड़ फोड़ मचा सकती है. So let us suppose one neutron breaks. So it will break into one proton and plus one electron. Proton is positive charge, it can stay into the nucleus, but electron is negative charge, it cannot stay into the nucleus. So this electron starts emitting from the nucleus. Such energetic electrons coming out of the nucleus, they are known as beta particle या beta rays. पहले से nucleus में कोई electron नहीं है. Nucleus has proton and neutron. But since energy in the nucleus is very high, so because of that high energy, any neutron can be broken. So if neutron is broken, it will convert into proton and electron. Proton is positive charge that can stay into the nucleus, but electron negative charge cannot stay into the nucleus. So this electron starts coming out of the nucleus. Such extremely energetic electrons coming out of the nucleus are known as beta particles. These are extremely energetic electrons. These are extremely energetic electrons. Energetic electrons emitted from the nucleus. Emitted from the nucleus. From the nucleus. since these are electrons, so they have negative charge. So these are negatively charged, negatively charged, negatively charged. The charge is minus q, that is equal to electron charge. Magnitude of charge is less than the alpha particles, so ionization potential will be less than the alpha particle, but still they have negative charge, so they have capability to ionize or attract positive charge. So these are having less ionization potential, than alpha particle. These are having less ionization potential than alpha particle. Electrons travel almost with the speed of light, so they travel with very fast speed. When they travel with very fast speed, they can penetrate human skin, but they cannot penetrate thin metal sheet, because in metals there is an electron cloud, and that electron cloud repel them, so retard their speed, so they cannot penetrate. So you can write these travels almost with the speed of light, They have higher penetration power than alpha particle. They have higher penetration power than alpha particle. They can easily penetrate human skin. They can easily penetrate human skin, but cannot penetrate thin metal sheet. This is all about the beta particles. These are extremely energetic electrons emitted from the nucleus. These are negatively charged. Charge is minus q. These are having less ionization potential than alpha particle. These travel almost with the speed of light. They have higher penetration power than alpha particle. They can easily penetrate human skin, but cannot penetrate thin metal sheet. Now you see, if you know electromagnetic spectrum, we have UV, VIBGYOR, IR, like this. So in increasing frequency, at the highest frequency end we have gamma rays. So gamma rays are not particle, because these are basically high frequency electromagnetic waves. Since frequency is highest, and you know that energy of photon is h nu, so if nu is highest, energy will be highest. So these gamma rays are extremely energetic electromagnetic waves. Since they are extremely energetic, they travel with the speed of light, so they can penetrate anything in their path. They can penetrate even the thick layer of concrete. So they have highest penetration power. But they are rays, so they do not have mass, they do not have charge. So they are massless and chargeless. Since they do not have charge, so they cannot ionize anything. To ionize anything, it should have some charge. So they have zero ionization potential. So the last one is gamma rays, and you can write about gamma rays. Third one is gamma rays. These are high frequency, electromagnetic waves. These are massless and chargeless. They have zero ionization potential. They travel with speed of light. They travel with speed of light and have very high energy. Very high energy. They have highest penetration power. They have highest penetration power. They can penetrate even thick layer of concrete, even thick layer of concrete. They can penetrate even thick layer of concrete. So this is all about the gamma rays. This was all about chapter 1. So chapter 1 got an end. In the next class we would be starting the chapter 2. Thank you. चैप्टर 1 खत्म होता है, नेक्स्ट क्लास में हम लोग चैप्टर 2 स्टार्ट करेंगे. दिस वाज ऑल अबाउट चैप्टर 1. टुमारो विल बी मीटिंग एट 9 AM. आज के लिए बस इतना ही. वी स्टार्टेड फ्रॉम हियर. आप पिक्चर ले सकते हैं अगर जल्दी से ना लिख पाए हो तो. टेक द पिक ऑफ अल्फा पार्टिकल्स या अल्फा रेज, देन बीटा रेज, and then gamma rays. Thank you.